I'd like just to talk a little bit about what we are working on in terms of adaptive machine learning for data streams. So, thank you. So, yeah, basically, with the pandemic, all machine learning models stopped working. So the thing was that there was a lot of changes, and then everything that was working perfectly, once the data started changing, everything started going wrong. So that's why this adaptability is really, really important also in terms of machine learning, right? What is a traditional approach? So the approach is that, okay, we build machine learning models and we do that periodically. So we suppose that when we build a model, we are going to use static data and that all the data is going to be in one place. So the idea is that we do that periodically. We do that every day, every week, every month, and how much data we use, so that depends. So maybe we use the data of last year, last month. So these are the two parameters, no? When we build the model and how much data we use. The problem of that is that it depends on the change, on the scale of change. No? If data is changing every day, if we build the model every week, it's not going to work, or the other way. So that's why this data stream approach is quite nice, because it is built in the idea of updating the model continuously. So we don't need to store all the data. So streaming is data that is arriving continuously. So we want to be very, very efficient in terms of resources. So every time a new example arrives, what we do is that we update the model, and that's all. And then we can update, and we can change the model according to that. So that's the nice thing of stream mining, is that we are very efficient in terms of resources, and we are adaptive, we detect changes, and we have these dynamic models. So just to mention some recent work, so this is the streaming random patches. This is work led by Heitor Murillo Gomez, and now is at Victoria. So the idea was to have something like random forest, but that could be used for any classifier. And then it's a very nice, it's an ensemble of learners that they don't see all the features and they don't see all the examples. So it's a very nice idea and very, very powerful, and it's getting very, very good results. And yeah, another work that I like to mention is this fairness classification. The idea is how we build learners that they are not discriminating for a specific feature, like gender, race. So it's really nice. The only thing that we need to do in this case is change how we build decision trees. Instead of using information gain, we use something that is using information gain and a discriminative index. So when we are splitting the tree, we are not splitting only in terms of information gain, but also in terms of reducing the discrimination of the decision tree. And finally, just to conclude about some open source tools that we have MOA. This is a software that is like Weka, but specific in Java. The idea is that it's really, really, has many, many methods, has been there for almost 14 years. We have methods for classification, regression, clustering, multi-label, multi-target, many, many things. We have this book that is open available, Machine Learning for Data Streams with practical examples in MOA. This is something that was written with Ricardo Gavaldà, Geoffrey Holmes, and Bernard Faringa. It's open available, so you can read it online. You don't need to buy it. We have another software that is River. River is a tool in Python. It's similar to MOA, but it's in Python, and it's becoming very, very popular. I think the reason is that Python is very popular right now. And it's a merge of two projects, Scikit Multiflow. There's a project that we started in Paris, and CRIM, there's another project. And yeah, it seems that it's quite popular. And we had the surprise that someone wrote a book about that. So we have this book that is Machine Learning for Streaming Data with Python that is already using River and focus on River. Good. Thank you very much.